Alright, so welcome buddies. In this lesson, we're going to discuss about the creation process of the dry ice. Now, like in the previous lesson, you must have seen the essential process of creating this proxy object. Now, what I did is that I have added another, you could say, the the smooth modify to this polygon object. Well, the reason why I did just that because I want more proper, intact, and better encapsulation of this proxy object. And one more thing which I did was that I just, selected some few edges which I do not need them at all, and they are really very, close to each other. So what you can just do that, just can select the alternative one and you can just get rid of them. So I guess this will help me in getting the low polygon shape of the object and also going to reduce the computational steps. However, it isn't like that too much of the impact we can generate with the fluids while dealing with some few more polygons. But like just to avoid the unnecessary calculations, I just have to do that thing. So for now, I don't think so. We're gonna need this high polygon object. So I do have a layer over here, and I guess so I can hide it up. But before just I make it hide, why just not I bring the low polygon over the shape again of the high polygon object, and now let's just put that thing to the height. Okay, now we are good to start to create the dry ice process. So I need to go to the dynamics section and have to create the 3D container. So this 3D container is really going to be big in comparison to the low polygon proxy object. So just to make it fit and to align that thing properly, I can select this low polygon object. I can go for the modify, something called align objects, and let me just get to the reset setting first. So the last object is the low polygon proxy object, and here in the setting which is called align objects option, it'll gonna fix the XYZ coordinates of the object, and we're going to place the target objects according to that. So I can use the align to the last selected object with Y again on and Z again on, and I need to click to the mid and let's say hit apply. So that's quite good. But here again you can see that I do have left with some spaces which obviously I can make it correct. So first of all, why don't we just again uh, take care of the size of our fluids. For that I can scale them down to let's say 5 by 5 from the X and Y, sorry, from the X and Z axis, and for the Y axis let's say 6 would be a proper start. You must be thinking about that. We Why we are doing this thing. Of course, I can tell you. So, uh, you may could also increase the size. Let's say you can go for 6 is not a problem, but the reason why I don't want to consider the big size because it obviously going to affect the base resolutions, and you can say the ratio of the base resolution versus the size. By saying this, it doesn't mean that you always need to have a very small size of the fluid container. No, but just try to have the basic 10 is to 10 is to 10. That's really gonna work perfect under all conditions. So again, now my emitter is set. So first of all, I just have to name that up. Let's say the dry underscore ice underscore fluid container. All right, we're good to go for that. And now again, what I have to do is that we can create the emitter. So under the fluid effects, we can go for the added contents. Let's say hit the emitter. In this case, I would like to go for the volumetric, the volume emitter instead of going to the default point emitters or the omni emitters. So, which is very easy to fix. What we can do is that we can go for the emitter type and can switch to the volume. And of course, what type of emitter I have to pick. This is really a very important question. You know, guys, what? Uh, while dealing with the different emitters, it obviously going to give me a different subtlety or different results. But that is not very important. The important thing is that uh, for this particular situations where you can see that there is obviously and more or less a cylindrical object, which is a low polygon proxy object. So what kind of shape should match with it? I guess the best shape would be the cylinder. But just for your knowledge, I would like to tell you something more about the careful utilization of the fluid emitter, which I will going to discuss with you in the next lesson with the example type, that how to prevent the leakage of the fluids uh, from the collision object. Okay, so earlier I opted for the emitter type tube, but sorry, the torus, but it doesn't work in my case. Okay, so it was happening like some of the fluids was getting passed away, some of the fluid was getting leak out from the collision object. So what I did was that I changed the emitter type, and I took from volume shaped torus to the cylinder, and with the cylinder again I set some few settings regarding the scaling. So I just crack down the y-axis and I increase the size of x and z, sorry, the x and z scale, but make sure that do not try to increase too much. It is again a cause of the fluid leakage. Okay, so we just don't want to do that. So I guess this much is something better, and I can scale them down from the y-axis a little bit more. Okay, so this is something which is good. Now what next we have to do is that we can select the fluid container, and we can select the low polygon proxy object, and of course we're going to give the make collide. Okay, with the tessellation factor set that thing to 400, which is default, works pretty much good, or you may could give it to 500 as well, and apply and close. So with that we have created the dry ice fluid emitter, the dry ice fluid container, and the collision object. Okay, so for the fluid emitters, let me just start with some few values and tweaks. Here in this case, I would like to have the density method only. In this situation of simulating the dry ice, we do not need the heat, since which is if you're going to ask technically, that will going to be completely on a different way, because there is no usage of the heat inside this. Okay, because this smoke is really going to be cold, that I've already discussed with you in the third chapter or second chapter, I guess, where I show you up that the dry ice exists at a temperature of minus 78 degrees Celsius. Okay, so there's no point of using the heat method, so we can just put that into no emission. Same implements to the fluid as to the fuel, so I'm not interested in using this again. And of course I don't want the fluid drop off, so for this let me just put that thing to the 0. All right, and for this reaction I prefer the density per voxel per second, the rate of emission of the fluid attributes, the density method, which is obviously add. I like to go for 8 as the initial start. I may could switch my value between 6.5 to 8.5. Okay, and one of the most important thing which I want to tell you is that the fluid emission turbulence, since you may could visualize that there are certain things which are making the dry ice to instantly pop out, which is basically two things. One is the density pressure, which we're going to harness this option inside the fluid container. But for the fluid emitter, I would like to have some randomness, or you can say the disturbances inside the emission, not a sort of a consistent uh, behavior of the dry ice which is emitting from the emitter. So I just want to have some little bit more variations. So let's say the turbulence, I want to have fairly high turbulence. Okay guys, so let me just put that thing to maybe 20 to 25. With turbulence speed, set that thing to 0.5. Turbulence frequency would like to go for 0.2 with 0.5 and 0.2, and the detailed turbulence obviously going to hit 1. And you're going to see that there is a significant role of this fluid emission turbulence options. All right, so for the next of the settings for the fluid container, we're going to continue this in the next lesson.